There are two main reasons why Earth has active volcanoes. The first is that it's alive with lots of microorganisms that produce heat through their metabolism. And second, Earth's interior is hot because it's still warm from the process that formed it. Other rocky worlds like Mars used to have these things too, but now they re cold to support life and have cooled off enough that their insides aren't hot either. So there's no way for new magma to make it to the surface. But some moons in our solar system have kept their interiors hot enough for volcanism despite being far from any significant source of heat. Take Jupiter's moon Io, for instance. Its volcanoes are the most active in the solar system. They're powered by tidal flexing from Jupiter's gravity. As the giant planet pulls on Io, it heats up its inside, creating magma that can reach the surface. Or consider Saturn's moon Enceladus, which has a similar situation, except it has the gravitational pull of the whole Saturn system that does the flexing and heating. These moons both have oceans on their surfaces and under their icy shells. These oceans are heated by the same tidal flexing that fuels their volcanism, keeping the water in a liquid state, even though it's more than 100 degrees below zero at their surfaces. But other moons also have subsurface oceans without any active volcanism, like Uranus's 5 known moons that scientists think have oceans beneath their icy exteriors. So why don't these moons have any volcanoes or geysers? To find out, researchers ran computer models comparing the interior structure and evolution of Uranus's moons with observations about the moons themselves. Their goal was to figure out what combination of factors could explain their lack of geysers and cryovolcanoes, which erupt materials like water, ammonia, and methane instead of molten rock. Their models revealed that all of the Uranus moons they looked at probably had oceans at some point in the past. But currently only one, named Miranda, has an ocean according to the model. Now this doesn't mean that the other 4 moons definitely don't have oceans anymore. It just means that their current conditions would cause any ocean to freeze over. But Miranda's ocean remains liquid thanks to how close it is to Uranus. So we know that the reason these moons don't have active volcanoes or geysers isn't simply that they reach cold. That's because it turns out that some parts of these moons are actually warm enough to be hospitable to life. But what the team found was another factor that plays a big part in the story: size. Uranus's 5 inner moons, including Miranda, range in diameter from 317 kilometers across to just 6 kilometers across. Scientists already knew that larger moons tend to have more heat inside of them due to the higher amount of radioactive elements like uranium and thorium in their interiors. But in this study, published in the journal Geophysical Research Letters, the team showed that the amount of heat produced by radioactive decay alone is not enough to keep a moon with an ocean warm enough to be habitable. They found that radioactive decay only makes the shallow layer of ice above the ocean warm enough to melt. It doesn't warm the rest of the ice shell or the ocean itself. For example, if Uranus's moon Ariel were any bigger, say the size of Earth's moon, then radioactive decay alone would generate enough heat to maintain an ocean beneath its icy surface. But since Ariel is much smaller than that, radioactive decay doesn't cut it. The smallest of Uranus's inner moons, Puck, is only slightly bigger than a dwarf planet. But scientists believe that it, too, once had an ocean, which means there has to be something else generating heat besides radioactive decay. And the answer lies in the fact that it's a moon. Like all moons, Puck orbits a planet. And as it does, it experiences tidal flexing from Uranus's gravity. We've seen how this works on moons like Io and Enceladus, which are tidally heated by Jupiter and Saturn respectively. But Uranus's moons are much farther away from the planet. So why would tidal flexing still affect them? Well, while the gravitational pull of the planet weakens with distance, the effects of tidal flexing don't weaken as quickly. Tidal flexing arises when a big body like a planet has a gravitational pull that distorts a smaller object like a moon, kind of like how Earth's gravity pulls on you. This tidal force stretches the moon, which creates friction and converts it into heat. So it's possible that for a moon to keep its ocean liquid, it doesn't need to be super close to its planet. Instead, it just needs to be big enough that the tidal force generated by the planet's gravity is strong enough to heat its interior. In other words, size matters. The team calculated how large each of the Uranus moons would need to be to generate enough tidal heat to keep an ocean liquid. And they found that while Miranda would need to be as large as Earth's moon to meet this condition, the other 4 moons would need to be about twice as massive as Earth's moon. Now, it's very unlikely that any of these moons will ever get that big. If they were any bigger, the material they're made of, mostly water ice, would collapse under its own gravity, destroying any ocean that might have been there. So the team thinks that while these moons did have oceans in the past, they likely won't again in the future. That's because as they slowly lose mass, either through impacts or by being eroded by radiation, they'll eventually become too small to be tidally heated by Uranus. At that point, any ocean underneath their icy surfaces will freeze over and they'll become permanently frozen solid, joining the ranks of the many other lifeless icy moons in the outer solar system. This research shows that size is an important factor to consider when looking at worlds beyond Earth. Moons this size do exist elsewhere. For instance, there's a similar-sized moon around Jupiter that's called Elara, so it is possible that this moon also has an ocean under its surface and it could be warm enough to support life. This discovery gives us clues about the habitability of moons in other systems, especially considering that exomoons are predicted to be much more common than planets. There are likely trillions of them throughout the galaxy. So, figuring out which ones might have life could help us find life elsewhere in the universe. So, next time you look up at the moon, just remember it could be hiding a whole ocean under its surface. And maybe someday soon we'll find out that it's home to all kinds of cool stuff. Thanks for watching this episode. We've made thousands of educational videos over the years, and we've been able to offer them for free because of our patrons. So, to all of our patrons, thank you for what you do to make this happen. If you're not a patron but you want to learn more about what that means, you can go to our support page.